We're going to balance this using the algebraic method. First, put down variables A, B, C, and D because we have 4 chemical species. We're going to create linear equations based off the quantity of each atom type on each side: potassium, carbon, oxygen, barium, and chlorine. Our equal sign in our linear equation will show up where our yield zero is. Notice we have 2 potassiums associated with A and 1 with C, and those are the only locations it appears. You'll do the same with all the other equations. If something occurs in more than one location, you'll go ahead and say things like 1D and 1C. You'll say things like 1C plus 1D. That didn't occur here. You're then going to choose one variable to be set equal to 1 and then solve for the rest. The one that we choose should have the highest number of coefficients, but also should tell us the most about all of the other variables. We're going to go ahead and see it as the wrap table, or the teeter-totter method, the seesaw method. It's more of a trial and error. And the wrap table, reactants, atoms, products, allows us to see which things are balanced and which things aren't. Here, potassium and chlorine are the only things that aren't balanced. We'll then go ahead and make adjustments to their coefficients in the balanced chemical equation, and then make adjustments to our math to determine if everything's balanced. We're also going to go ahead and make sure that we see that the wrap table and the linear equations are basically the exact same thing. The linear equation simply has an equal sign rather than 2 halves, shown with a breakup of the atoms, and also it has variables that look like they're in the way, and this can be confusing for many students. Notice the quantities in the wrap table and in the linear equation are ultimately the exact same thing. Here, it's very easy to see because everything only occurred in one location on each side.